Hello YouTube, welcome back. Today's video is going to be about taking a DOF Reality box like the M2, which only comes with two motors or motor controllers in it, and adding a third motor controller so that you can branch off and add a third motor to your sim rig. Now I just wanted to say a couple things about the process before I get started. Number one is that the software I'm using is not DOF Reality software. What I've done is I've gotten an extra Arduino board and I've flashed it with the open source, I believe it's the SMC3 file that you can find from X Simulators. It's basically the open source, kind of open source version of what DOF Reality runs, but it's not compatible with SRS, the Sim Racing Studios software. So you have to use sim tools with it. Now, you could probably add a third controller to the box and use the DOF Reality software, but this video isn't really going to be about that. So if you're attempting this, just know that you may run into some issues with software if you're not using the open source SMC3 file like I am on my Arduino board. It's a pretty easy process if you want to check it out. Just go over to xsimulators.com and look for it. I'll link a description in the video as well. There's also some 3D printed parts that I designed and am using to help with this, and I'll link those in the description of the video as well if you want to download them and print them. And they're only really going to work if you get the exact same items that I'm using for this as well. And with electronics, there's always many different ways of doing something, and as far as the components that you choose. So I will link the components that I selected, but you're certainly welcome to use your best judgment. If you want to use different plugs or something like that, then by all means make a decision that works for you. I'm just going to show you what I did as far as this build goes. So let's get into it. We're going to start taking the box apart and we'll talk about it as we go. Okay, so here's the DOF Reality box that you may be familiar with. This is from the M2 and it only has two motor controllers in it. So first thing we're going to do is take this panel off. It's just a bunch of screws. So just take these screws out and then take this top panel off so you can get inside. Alright, I've got the panel off. Now I've already been in here and I've already done some stuff, so you can ignore a few things as far as wires being disconnected and stuff like that, but let's talk about what we have here first. So we have our Arduino board here, and then we have two motor controllers here and here, and then you'll have two power supplies. You can see I've already got a third one in there now, but you can ignore that and pretend it's not there. You'll have two power supplies. Now each one of these power supplies sends power up to the motor controller, and then from the motor controller it gets a signal from the Arduino board, and then it sends power out the other side to your actual motor. So let's take a closer look at the Arduino board. So on your Arduino board, again, I took this board out, the original one, and I saved it, and then I replaced it with a new board, and then I flashed this board with the smc3.ino file. So what you're going to see here is these pins, which are A0, A1, and A2. Right here, these first three pins are going to be the sensor wires. So the wires coming off of this are going to go to your Hall sensors. And then what we have here is the pinouts for the actual motor controllers. And here they're using one ground and one sensor wire, and then over here there's power, 5 volts I believe it is, that goes to the motor controllers. And that's about it. There's also pin 6 here, which is not currently used, and this is going to be the third motor controller. When we get one in, we're going to use pin 6. Alright, let's take a look at the motor controllers. Okay, on the motor controllers, this is the model that you're going to want to order. And it's made by this brand Citron, and it's an MD13S, and I was able to find one on Amazon. So up here on the leads coming in, we're going to have ground as black, power is red, and either green or blue is going to be your directional or your sensor wire. And then the only other wires to worry about is going to be your power coming in, which is the green side. You're going to have a negative and a positive. And then the power going out to the motors, which is the black, negative and positive. So I would highly recommend taking a picture of everything, multiple pictures. So in case something gets unplugged or you get confused, you can refer back to the pictures that you've taken. Okay, let's take a look at the actual power supplies. So these are the power supplies. There's 3 of them here. And then they're held in place on the back side of the unit. By 2 bolts on either side. And when you're putting the new one in, the easiest way to line up the holes is to look for this switch here where you can switch between 115 or 220 volts. For the most part, probably most people are going to be keeping it at the 115, but just line that switch up through this opening here, and then these 2 holes will be a lot easier to find when you're putting the screws in. So what I would do is just pull a screw out from an existing existing power supply, and then match it up and find 2 more for the additional power supply. Okay, I've pulled the 3rd power supply out. This was the new one that I put in, so we can take a look at it. Before I put it in, I took a Sharpie and I just marked it as new. So just in case I got them mixed up or something like that, I would know that this was the new one because they look identical. And when you're ordering this on Amazon, this is the model that you're going to want to look for. This LRS-350-24. So it's a 24 volt, 350 watt power supply. And we'll look at the wires coming out here. So again, you're just going to want to match up your wires exactly how they are in your other power supply. So you're going to have a hot wire, which is your L, which is red. I'm going to call it neutral, which is your blue, and then ground, which is your black. And that's the AC power coming in from the wall. And then the power going to the actual motor controller is going to be this positive voltage here and negative voltage there. And that's going to be your 24 volts going to your motor controller. And there's also 2 TV diodes that DOF is running as well. And my understanding is that they're kind of act like a filter, just to sort of add some extra protection to the motor controllers. So those go on just on either side here and here, on either side of the red and the black wire. And then I'll show you how these wires here connect up to the next power supply. Okay, so what I've done is I've unscrewed all 3 power supplies from the actual box. So then you'll be able to pull them out and take a look at how the wires connect. It's also worth mentioning I've taken off this faceplate here as well. So again, when you're taking things off, just take pictures, make notes, however you got to do it, so you remember where wires connect back up. So then if we look at the way these are wired here, you'll see we've got, this is the power from the wall coming here. We've got a yellow and green, a blue, and a red. And those go into the first power supply. And then they just loop over and go to the next power supply. So basically what you're going to do is just copy that and just, you know, match colors. I used black for the green and yellow. I used blue for the blue, and I used red for the red. And then the wires coming out here are just for your motor, or for that they go to the motor controller. I'll take a close look here. So you can see they're just held in by the screws. Now what I did was I just, on these wires here, I just tinned the end with a soldering iron and then just loosened the screws up, slid them in, and then clamped down. And then once everything's tight, just make sure that everything is in there securely, nothing's loose, nothing's going to pull out. And that's really all there is to it. Just match up your wires and just follow exactly what's already there. And then put your TV diodes in just like they are up here. Now, I wasn't really able to find a directional marking on these, so I just followed the way that the lettering was, and I just matched, you know, these letters are right side up or upside down, however you're looking at it, and I just copied that on these ones there, and it seemed to work fine. So once you've got everything wired in, you know, make sure you've got your motor controller wires in, your diodes, everything's tight, nice, and you'll be able to put these back down in and then secure them all in place with the screws. So the easiest way is just to flip the whole thing upside down, so it's just sitting on top of the power supplies, and then look through these little windows and line up the red switch so that you can have somewhat of an idea where you're at. And then once it's lined up, you can just drop your screws in. Just like that. And then just do all three. So this is kind of nice because the box is actually designed to accept a third controller, and so everything is there for you. You just have to add to it. All the holes are there for the screws and everything. It just gets a little bit more complicated when you start wanting to add the actual connector and stuff for the motor. But as far as the motor controllers go, the power supplies, everything is here for you, ready to go. Okay, all three are in nice and securely. So we'll just flip it over and then we'll just take a look at our wires, make sure nothing goofy's going on. You can just kind of route this up through where these wires go. Just take a look down in here, make sure that nothing is pinched or crimped or anything like that. Okay, I think I'm going to take this break in the video here and talk a little bit about what I'm using. So the wires, this is a 16 gauge wire that I got off of Amazon. It's kind of nice because these are connected together, and this is adequate for all the wiring that I've showed you so far. You will need to get one additional color. Maybe you've got something laying around or whatever, but you know, a blue wire or something. You don't want to use black and red and then another black, or black and red and then a second red, or second red, because it's just going to get confusing. So definitely get a third color. For this, you could use the 16 gauge, or you know, a 14 gauge would be fine as well. And then the TV diodes, again, I will link all of this in the description of the video, but this came as a 5-pack, and they're easy to bend, so you can just use, you know, like a pair of pliers like this. You can just bend the end however you need to get it to fit into the power supply. You will also need some PCB standoffs. These are for the motor controllers. I actually had a hard time finding the right size. I ordered some, but they were too big, so I just 3D printed some. And again, I can link that in the description. What else? You will need one of these rotational Hall sensors. And then again, I've 3D printed this mounting block here, and I've elected to use the RJ connector. And just pick, I picked red, yellow, and green, and just soldered those on. And then you can just, plug it in, and then we'll have a matching one of these plugs on the actual control box as well. But you'll need one of these, to pair with your third motor. And then for connectors for the actual motor, these are XT90s, but they're nice because it has this mounting flange. But these will handle a lot of amperage, and this will go on the box, and then your motor will plug into it like that. And it's got this little decorative piece that can go on the back side of the wire coming from the motor. And then obviously you'll need some RJ12 or RJ14 telephone wire for this connection here. And this idea was stolen from the newer DOF Realities that use this. So you'll need some of that. And then for the wires going from the control box to the motor, you're going to probably want to run a little bit thicker wire. So I got a couple rolls of 14 gauge wire, a red and a black. Okay, let's talk a little bit about the faceplate. So you could elect to take the existing faceplate and drill holes in it or cut out holes, whatever you want to do to accept whatever style plug you've elected to go with. So that would be one option. What I decided to do was 3D print a new faceplate. So this is what I came up with here, and again I can link this STL file in the description. So you can see here I have the original motor plug and sensor plug for motor 1 and 2 here. And then the original on-off switch, and then this is where your USB port is for the Arduino board. And then I've added power to the third motor and the sensor wires for the third motor there as well. If we look at the back side, we can see that this is that telephone connector here that I was showing you. It's the same one that I used here. So that just screws to the back of the faceplate there, and then the XT90 connector screws in there. So I think that came out pretty sweet. I used a carbon fiber textured build plate to give it a little bit of bling. So this is what I'm going to be using. And then all those screw holes and everything, so that it can just screw right in. So this is the solution that I came up with for the faceplate. Okay, so before we go any further, I wanted to swing back around and talk about a couple of things, because I was editing this video last night and I realized I missed a couple things that I wanted to talk about. One, I did make a note of it, was this Arduino board here. This board here is actually like a piggyback. It sits on top of the Arduino board itself. And all you got to do if you were going to replace the Arduino board is just pull it off. Just wiggle it, and it actually comes right off like that. And then the actual Arduino board sits underneath here, and this is just a piggyback board, so all these little pins here and these little pins here fit perfectly into the Arduino board, and it makes it a lot easier to see your pinouts and hook up to it. So At any rate, this is the Arduino board. This is just a piggyback board. So if you were to replace the Arduino board, this is what you're replacing. And then you would just reuse this board here. And then to put it back on, you just very carefully make sure all of your pins are properly lined up. Starting at the back of the board here, this pin lining up with this first pin here. Just make sure everything's lined up, and then just drop it back down in place there. The other thing I wanted to mention was with the power supplies, these wires here and the other wires that are going into the power supply units, like I said, I tinned the end with soldering iron and clamped them down on the screws. You could certainly get a connector of some sort and crimp it onto the end of the wire and do that instead. That's totally fine. So before moving on to installing the third motor controller, what we want to do now is make sure that we've actually got 24 volts coming out of our new power supply. So we'll go ahead and plug in the box. And we will grab a multimeter. And on the multimeter, we're going to want to go ahead and set it to volts DC. You want to make sure that you're at a range above 24 volts. So here I've got 20 and then 200. So I'm just going to go right up to the 200 volts DC range. And we'll go ahead and switch on the box. And then the two wires coming from your new power supply, we're going to go ahead and test them and see what kind of voltage we're getting. And we're getting 23.9, which is close enough to 24 volts that I'm happy. Okay, so let's say you tested it and you're at 23.7 or less than that, or maybe you're over 24 volts. What you want to do is adjust the voltage with this little screw down here. You can see it right there. There's a little screw. It's a little easier to see on the second power supply. So right now we're at 23.7 volts. And then it's an awkward position, but I will get this screwdriver in there, and then I'll slowly rotate it. We'll watch the voltage change. We'll get it right at 24 volts. So that's how you adjust the voltage. Okay, moving on to the motor controller. So here is the new motor controller. I'll unbox this real quick. Now, you may be able to find a better version of the one that I got, but what I have here requires a little bit of soldering. So here's the new controller, and you can see the pinouts don't have anything on them. And then when you get in this little Ziploc bag is just the little wire harness and then the two pinouts that need to be soldered on. And I didn't realize, or I just wasn't thinking about it, this does not come with a heat sink. So I just ordered a PCB heat sink for this as well, and I'll link that in the description. So we're going to solder these on here, and then we'll go ahead and get this mounted in the box. Alright, I'm going to attempt to do this on video. So we'll fire up the soldering station here. And we're going to use a relatively fine tip. So we've got black and green, and then we've looked at the two sides. This is where the wire's going to go in, so we want to have it facing out. And it's going to go in these two holes here. And it'll poke out the back. And then the green one's going to go on the left-hand side. And again, make sure you turn it so that the wires can go into those little holes there. So it's going to sit just like that. And then we just need to solder these 4 points here. So I'm going to take a little bit of this flux. And I'm just going to take my solder, get a little bit on the end like that. A little bit of flux on the end of the solder. And then we're just going to go to town. We'll melt the flux a little bit. Just going to get a little bit of flux on the connectors first. And then we'll actually solder. Alright, there's one done. And we'll get a little bit more flux on the end of the solder here. There we go. Now I'm just going to take my multimeter and set my multimeter to continuity. So when I touch these two leads, it should beep. I'm just going to check between these two and make sure that none of my solder accidentally touched each other and shorted out. So I should not get a beep when I touch these together. Nothing there. Nothing there. So we're good. Now I'm just going to take a damp rag. I'm just going to wipe the excess flux off of this. Just like that. Now, hopefully you can find a board that already has these soldered on, because otherwise it's, you'll have to do that. Okay, now we are ready to install the new board. into the control box. Now, I 3D printed these PCB standoffs. You could also, you can try and find the little plastic ones that DOF uses. These little guys here. I couldn't find it on Amazon. The other thing you could do is use like a brass or metal PCB standoff. You might have some of these kicking around from, building a computer with like a motherboard or something, and you probably could make these work. So I'm just going to go ahead and try to use my 3D printed ones. We'll see how that goes. Okay, so I was basically hating those 3D printed PCB standoffs. They were too wobbly. So I dug through my computer junk and I found some brass motherboard standoffs. And what I'm going to do is take just a standard computer screw like this, which has the same thread on it as the standoff. And I'm just going to kind of tap out the holes in this metal rod here. Get some threads started. And then we'll go ahead and put the brass standoffs in. Not the greatest solution, but I think it'll work. Then we're just going to go ahead and use 4 little screws to secure the PCB to the standoffs. Okay, now that's in. Now you do need to remember that you need to get a heat sink on the bottom of that. So when mine come in tomorrow, I'm going to pull this back off and put a heat sink on the bottom of it. Okay, so now we need to deal with this connector here. And we're only going to use 3 of the 4 wires. So the ones that are used are ground, skipping NC, using PWM, and direction. So ground, power coming in, which is actually like 3 volts, not 5. As I said before, it's 3 volts coming in, and then your sensor wire direction. So here, the red wire is the NC. So we're not going to use red. We're going to use black, white, and yellow, at least with this wire harness that I have. So what I have here is some pin-out ribbon cables, and they have a male end at one end and a female end at the other. And we're going to go ahead and see if we can match up the colors. Alright, so we've got yellow, black, and white. And with the male end, we'll just go ahead and put those in this connector. So yellow to yellow. White to white. And black to black. And then in the Arduino board itself, or the piggyback I should say, our power wire is the white wire. So we're going to go ahead and put that right next to these red wires here. So this first row of pins, the S, is 3 volts. The second row labeled with V is 5 volts. So you're not going to use that. You're just going to use the first row at S. Right in line with these 2 red ones is going to be your first power connection. And then we're going to do ground because that's easy. So black is going to be our ground. And we're going to go to pin 6 at the top, labeled G. And then our last wire is the yellow wire, which is our sensor wire, or you can call it directional wire. And that is going to go to the S, or the bottom pin, also on pin 6. All right, now I'm just going to take a little bit of electrical tape and tape up that one connection. Just kind of tuck the wires in like that. All right, now we need to get our power wires coming in from the power supply. We need to have those coming in. So let's do that now. So these are the power wires coming from the new power supply. Just feeding them up through here. And they are going to go into the green side. So we'll just make sure we've got enough length here. That looks good. And then we're going to go ahead and cut the wire. We'll strip it back. We'll fire up the soldering iron and just tin those real quick. Okay, before we tin these wires, we're going to want to remove about half of the strands. Otherwise, they're not going to fit in there, at least with the 16 gauge wire. So I'm going to remove about half of them there, and then remove about half of them there. And I'm going to just go ahead and trim those off. And then what's left, just go ahead and twist it nice and tight. And then we'll tin those. Okay, now we're going to put red into the left-hand side of the green box. What you can do is if you get a little bit more wire sticking out than you'd like, you can just go ahead and trim just a little bit off the end. Go ahead and tighten the screw down. I'll loosen this one up a little bit more. Trim just a little bit off the end of this. Now what you can do is take a pair of pliers and sort of support this block so you're not twisting it in the circuit board. Make sure they're tight, they're not coming out. Now we're going to take another piece of wire and we're going to do the same thing. This wire is going to go to the actual motor itself. So same thing, trim, tin, install. But you're going to want to leave yourself some extra wire here because you don't know how much length you want. Okay, once you've got your wires in, you'll take some zip ties, just kind of clean everything up a little bit. So I'm going to just scooch these wires up a little bit. I'll put a zip tie around here. And then these wires here will run across over here. And then we'll run them down through this little notch. Pull them back a little bit, give it a little bit of slack. And there you go. Okay, now we need to get our faceplate back on. So here's our faceplate, and the first thing we need to worry about is the new sensor wire that we have here, which is the RJ12 or RJ14 connector. So again, I'm going to use these little jumper wires here, and what we need to do is take a look at the sensor that we already soldered up, which is right here. So I used green for ground, yellow for sensor or out, and then red for voltage. So that's our reference. Need to match these color wires coming out of this RJ14 connector and match it to the colors that we chose on the sensor. So we know that green is ground, and these I'm going to use as my colors here. So I'm going to do brown is ground, so brown will go to green. And the next one is the sensor wire, which is yellow, and I'm going to use orange for that. And the last one is red for voltage. So we'll go ahead and put our red wire and match it up with the red wire on this plug. Make sure everything's in there nice and tight. Red to red, brown to green, orange to yellow. And then I'll put a little piece of electrical tape on this. Okay, now we can start mounting the faceplate onto the box. So you can see it's marked. N is for ground and L is for positive. I'm thinking neutral and line maybe, but at any rate, I mean ground is actually up here where they don't use ground, so N is ground, L is positive, negative, positive. Maybe N is a negative, negative, positive, whatever. You'll see here on these sensors that the wires are different lengths. So the one with the longer wire is going to go farther away from this USB port. The on-off switch in the USB port needs more length to reach over there. So your longer wire will go farther away from that side. And then the sensor port with a shorter wire will go into the closer hole. Longer power wires. And then the sensor wires run up along here, and then they kind of tuck behind the Arduino board and come over that way. A little bit of luck, everything will fit. So you can see everything fits. I'm going to go ahead and get some screws in the bottom of this thing. Alright, it's getting a little hard to see things, but the faceplate is on. Kind of see everything there. And then I still have this extra wire here for the motor, which is going to need to come out through here and get attached to this plug. I've got the 3 sensor wires coming up here from behind the Arduino board. So let's go ahead and get those plugged in. Alright, the first one is going to be the blue. And that's going to go to our A0. The next one's going to be green. That's going to go to our A1. And then A2 is going to be our new sensor wire. And if we remember right, we look at these, we've got negative, positive sensor. So our brown wire was our negative. Our red wire was our positive. And our orange wire was our sensor. Just like that. All right, I've plugged the on-off switch back in, and now really the only wire left we have is the new motor wire. So what I'm going to do is pull this. I already took the screws out. I'm going to pull this XT90 connector out of the faceplate. And then I'm going to guesstimate how much wire I'm going to need. And I'm going to need to come out a little bit because I need some room to solder. So I'm thinking right about there would be good. I'll go ahead and cut that. Then I'm going to run this through and out like that. I'll go ahead and get these soldered up. There's one. Do this one a little bit differently. I'm just going to put some flux in here first. I'm just going to set this wire in there this time. There we go. Now we can go ahead and slide the connector down in there. Got a little bit of extra wire, but that's okay. You can just tuck it around in there somewhere. That'll be just fine. There you have it. So that's basically done. I just need to get a heatsink on the bottom of this, hook it up to the computer, make sure everything is working the way that it should, and then put the cover on. But that's going to do it for this video. If you have any questions, let me know. And hopefully you found this helpful. We'll see you in the next one.